Hello, how are you? Can you hear me? Hello and welcome to the class. Hopefully you can hear me. Hello? Okay, good. I'm glad you can hear me. Okay, we'll just wait until the rest of the students arrive before we get started. But is there any questions that maybe you have until then?
Yes, teacher, I want to ask about the project you need. I want to ask about it, please.
Okay, good. Yeah, we will
write or program.
Well, we're going to talk about that. There's going to be several options. Obviously, the best is that you write the program and it runs and it's successful. However, you can just write it and then you'll get some credit. However, you will be able to keep working on it. I'm asking that you submit something to me on Saturday, but if you want to keep working on it and then you finish it before the end of this class, then you can submit it again for more credit. So I'll let you work on it for the entire session if you didn't get a chance to finish it. This way you'll have a chance to, keep working on it, learning more as you go. So I will talk about that in the class. And I did give you some help with it by giving you the C programming language code. Also, I will discuss some other views on this program assignment so that perhaps by the end of 14 weeks or 12 weeks, whatever, last day, maybe by that day you'll have it completed. And that'll be the same for all the programming assignments, because 1 week is kind of short to create a program, especially if you need to work on it or if you're new to Java. So I just want you to start looking at it and thinking about it. Some of you may finish it. If you don't finish it, then you have all the way until the end of the class session to submit it again if you want, if you continue working on it, and then you can get more credit. How does that sound? Hello, I'm good. How are you? Good to see you. Did that answer your question? And I like that you used the microphone. It was good to hear you.
Yes, Doc, please, we want to ask about the deadline of project. Can you give us 2 or 3 days after Saturday so we can finish? Because until now we cannot understand what we have to do.
Right. Yes, you can have an extension, but you still have to give me something Saturday to show to me you're working on it. But then you don't even have, you can have more than 2 or 3 days. You can have all 12 weeks. Or how many more weeks do we have? 10 weeks? You can have all those weeks to work on it until you finish it. Last day of class, you can turn in all programming assignments if you have a chance to keep working on it. Because I am a programmer, and I like to have time when I program as well. And this way you have more chance to think about it, and I think you'll learn better than to do something fast, just to do something but not understanding what you're doing. So, like I said, you have the opportunity to keep working on it all class, all session, and then give it to me at the end or whenever you find you did finish it. So that's for all programs in this class. But do remember, the programs themselves are a small portion of your entire grade. So it's really not a big part of your grade. However, it's good to know, and if you like to program, then obviously you're going to want to do it, and you're going to have fun doing it because you like to do, programming. Not everybody likes to program, but if you do, then I'll give you the whole 10 more weeks to do it. But just so that I have something Saturday, give me something on Saturday, and that's what I'll tell you what you can give me. There's some options to give me, so I'm going to give you some points, and then keep working on it so that you can get all points. And I'm always around, too, if you need help to talk about it. If you look in the classroom, I gave you some examples, some videos. I hope it's okay that I put those videos there. I wasn't sure. I'm new to your school, so I hope it's okay I put those videos. If there's a problem, let me know, because then I'll take them off. But I think it's sometimes helpful to see it in a visual form like that so that you can have an understanding of the logic. The logic is the most important. Okay, thank you. And then I gave you some example Java code. Again, if you look in the office hours presentation, you have some links. And also you have some links in the discussion forum. And there's one example, the sleeping barber. And that I gave you the program. And that one is the sleeping barber problem program is very similar to sleeping teaching assistant. So maybe that will help you, too, to understand the logic. I think the logic you probably will have no problem with. You will understand the logic. It's a matter of just getting more practice with programming in Java that'll take you the time. So that's why you have all the way until the class to program it. But I want you to at least understand the logic by Saturday. And we'll talk about it during this session to get started and give you an understanding. But these, as I mentioned before, these types of problems or strategies are used in a lot of areas, not just operating systems. They're heavily used because these days all applications are so complex, so sophisticated. Like if you do any of those video games, or if you have any network applications, you have a lot of processes going on, and a lot of processes competing for resources, sometimes at the same time. So you have to use these strategies so the game will work, or the network will work. So using threads and using semaphores, which is two main concepts you should walk away with this, are used very heavily in many areas, not just operating systems. So understanding the logic is probably the most important, because this logic applies to any programming language. If you're going to be doing video games, you're probably going to be doing it in C, and the programming language is C and C++. Java, if you're going to do some web development and some kind of distributed computing. So it's understanding the logic. Later you can always work on the syntax of a programming language, but the syntax of a programming language is not the logic. So it's the logic that's most important. Once you understand the logic, then whatever programming language you learn, you'll be able to use that programming language then to write the program. So it's the logic that's most important than anything. Okay, so that's what you learned about in week 4. We went through, as you read the chapters and looked at the videos, hopefully you looked at strategies to make sure that processes work, they communicate together, and there's no crashing of the programs. Now sometimes we'll learn, sometimes there's just no way out and a program will just crash. I think anytime you use a computer, you'll find that your program just crashed, or somebody else's program did crash, or some application just crashed. Yeah, sometimes it just happens because we can't control everything that's going on, because there's such a high demand for resources, especially with the use of so much graphics. When you have video games, not only do you have graphics, you have artificial intelligence, you have physics going on, you have mapping going on. So you have a lot of things going on at the same time. And that's the same thing with any kind of software application. The more sophisticated the application, the more you need the use of these threads and the use of these synchronization and deadlock strategies. or just if you have multiple users using the same application at the same time. For example, if you have a database and you're updating a customer record, and then the billing department is trying to send that customer a bill. Well, they have to wait till you update that record with the new address, for example, so the bill is sent out to the correct customer. So there has to be strategies to make sure, well, some jobs have to get done first before another job can start. Or can they work together at the same time? Sometimes that could work, but then you might run out of memory and when it's like that. Or you don't have enough processors to do all of them at the same time. So it's a lot of strategies, and this is your glimpse into the strategies that are used. Those strategies that have like scenarios tied to them, such as like the dining philosophers or the banker's algorithm, well, because they have names and scenarios associated with them, they are the more popular ones. So they are the ones that you should concentrate the most about, or most on, because they are used a lot. If somebody went so far as to make videos on it, make code in different languages on it, that means it's pretty important, so you should try to understand it. So again, there's a lot of material you're going through, but do know I am giving you example and optional exercises, and you have sample questions, and these questions will help you when you take the midterm and final exam. Those are probably the most important for the class because they are the largest part of your grade. So as for the programming assignment, it really is a small part of your grade, but again, as I mentioned before, and as you're all coming in, I will talk about it again. The logic is the most important, and you can give me something on Saturday. You maybe didn't finish the program, or it's maybe not running yet because you're new to Java, or you just don't know Java that well. That's okay. You can continue working on it out for the next 10 weeks. And then all programming assignments, you have until the last day of class to turn them in again if you want more credit. So it all depends on how much time you have. I know it's busy and it's a lot. Again, I like to program, and I like to have my time when I program because I want to make sure I understand it. I have time to plan it. I have time to fix the mistakes or errors. You always have to debug the program, and that always takes time. And also, if you're learning Java syntax, some of the syntax you didn't use in your Java class. It's new to you. So at least you're going to see it in the C programming language when you read the textbook. And then I gave you some Java examples as well. There's a lot of Java examples that I gave you. So just start looking at the examples and start understanding what that code means. Some of it you'll understand right away, no matter what language it's in. For example, you understand what an if, then, and else statement is. You understand what a while loop is. So those things right away will jump out at you because you've done it. It exists in all programming languages. It's just a matter of how do you exactly write it in Java as opposed to C. But it works the same. A while loop works the same. If then else decision statement works the same no matter what programming language you are using. So the logic is the most important at this point. But if you want to then continue working on it so you actually learn Java and run it in Java, then go for it. You have all class session to do that. But it's the concept that's most important, and again, your midterm and final exams are multiple choice. You won't have to write a program for the exams. So it depends how much you want to, split up your time. Like even after the class is ended, you can keep working on your programs. You can keep working on it because it's practice. The more you practice, the more you know. But just because the class has stopped, that doesn't mean you can't keep still working on it. Sure you can. Okay, so back to our material, concentrating right now on summary of week 3. We went over process scheduling. Again, hopefully these summaries will help you then repeat the material so it's easier when you study. And again, you do have those sample questions with the answers. I will give you the answers to the week 4 sample questions on week 5 office hours. So every Monday I give you the answers to the questions from the week before, and then every Monday I'll give you new questions that you could work on during the week, and then use that as a study guide for your midterm and final exams. But we did look at scheduling, how things were scheduling. First come, first serve, round robin. They're preemptive, non-preemptive, priority, non-priority. So hopefully you have a good understanding, and you know that statistics were used. You had to compare the strategies somehow, and statistics were used, and these were the numbers that were used, and some of them you had in your exercise problem. These are the things for the process scheduling. So as you go through this, as you study, make sure you have it, you understand each of these topics, and you can talk about it. Okay, now week 4, we're looking at synchronization and deadlocks. Again, a lot of material, but getting the general idea is we need some strategies so that when processes are competing for resources, we know how to let them function. They can't sometimes work at the same time because that may result in a deadlock. Neither of them will get anything that they need to do. So there are some strategies, and they're typically known as flags. I call them flags. It's a matter of, can I go, a process just asking, can I go yet? If I can't go yet, then I gotta wait. But it'll allow then for the processes to put some order into when they get processed. There's mutual exclusion locks, and there's semaphores. These are very important items to take away from this chapter. And then also when we go into chapter 7 about deadlocks. So when processes cooperate through shared data, mutual exclusion must be provided to ensure that a critical section of code is used by only one processor thread at a time. Now, critical section of code means this process has some code that can't stop in the middle. It has to finish until it reaches the end. Otherwise, the process won't work right. Okay. So there are some parts of code that have to run from beginning to end, and there's some parts of code that don't. So this is a way of making sure that at least those parts of the process that has to finish from beginning to end does get done and not interrupted in the middle. Because if it gets interrupted in the middle, it won't be able to recover, it won't know where it left off, and then the program will crash. So these mutual exclusive locks are used, and semaphores. These are strategies that are used to make sure one waits before the other, when another process is processing its critical section. That's for sure when it has to wait. Now, we did learn about scheduling. Sometimes it would be a higher priority. That means that higher priority process is like a critical section. In other words, it has to finish completely before our next process can continue. So it kind of all works together. We have these locks for critical sections, but these critical sections can be just a piece of the code, or depending if it's non-preemptive and high priority, it may be the entire process. So they kind of work hand in hand, again, depending on what situation you have and what scenario you have. So there's mutual exclusive locks. There's monitors. In other words, it's just checking. Monitors means it's looking. It's looking to see. And then when the monitor sees that a process is done, then it says, okay, another process can go. Or a condition variable. This means, well, when this variable reaches the number 10, then I know I can switch processes. That means one process got finished and the next one can go. So it's a matter of when to make processes wait or when you let processes process. These are the different strategies that are used. Now, these are actually methods. If you're talking about object-oriented languages, you're going to have methods. Some methods are wait, signal, sleep, Or if this variable reaches number 10, it could be a whole while loop or a for loop. So it's just a way, depending on your situation, to determine when a process or a thread has to wait or when it can process. Usually there will be some conditions that are there when you write the program that will let you know when it should or shouldn't continue. For example, with our teachers, a sleeping teacher assistant problem. Well, we know that a teacher assistant will sleep when there's no students. So that's our condition. So this condition can be based on something that's true or false, or it can be based on a number. It can be based on flags. There's all kinds of strategies, but it's just a way to let your program know when some code should be processed or when it should wait. That's overall the way, overall general look at this picture. So concurrent access to shared data may result in data inconsistency. Obviously, we got to be careful when we have many programs, especially if they're sharing data. Just like my example before, if I'm updating a customer record, I can't send the bill before that customer record is updated with the new address. So we have to determine when we look and write, if you are going to be programming, you have to look and determine what can wait, what can't wait, what has to finish before another action can be taken. So depending on your scenario, we'll kind of tell you what it is you need to do. That's why a lot of these algorithms have scenarios like the dining philosophers, the banker's algorithm, the reader-writers. Now, if your scenario matches something similar to one of those, then you know right away the logic that's used to solve that problem is the same logic you will use for your program. That's why I gave you the example of the sleeping barber. The sleeping barber example is very similar to the sleeping teacher's assistant. So whatever logic is followed in that one will pretty much be the same kind of logic you will follow in the teacher assistant. So that's why they put names around these problems with the solutions. Because if you ever have a situation that's similar, it could have a different name. Instead of dining philosophers, it could be dining teachers. Okay? But the logic will be the same for the program. So that's why they have these logics pointed out to you, because you will use them over and over and over again. So that's why learn them now well here. And then later on, as you have to write programs for different situations or different environments, you will find that it's similar to one of them, and then you can just use the same logic and sometimes the same code, you just change the names. So that's why they have these targeted, that's why there's discussion on this, and that's how it will help you. But that's just the whole point of reusable code and object-oriented programming. In general, it's reusable. A lot of logic that you do is reusable. The names just might change, the numbers just might change, but the way the program works is the same for many situations. So in this chapter, we're going to discuss various mechanisms to ensure the orderly execution of cooperating processes that share a logical address space so that data consistency is maintained. So we're talking about shared data space. If there's no shared data space, then you don't have to worry about them running at the same time because they're going to have their own space. So it doesn't matter what one does with their space because I don't have to use their space. See, again, it's just a matter of analyzing the scenario that you have to determine if you have to use any of these. Now there's something called producer-consumer. This is where two processes share a fixed size buffer. Now why do they do these kind of strategies? The reason is memory is at a premium. Again, With our sophisticated programs now and applications, they are competing so much for space. You know yourself, sometimes if you have an application and you don't have that much memory, it runs very slow, or maybe it doesn't run at all. You might just have a message come up that says, out of memory, and it just sits there. So you have to restart your computer or cancel that task. So that's why they're using these strategies as much as possible, because there is so much going on with the newer applications today. Just graphics alone takes a lot of space, and working with graphics takes a lot of time and processing. But if it's using the same fixed size buffer, and these processes do not take turns accessing the buffer, they both work concurrently. However, they can't both be accessing the same buffer at the same time, because you don't know what data you're working with. Are you working with processor number 2 data or process number 1 data? So again, there has to be some kind of signals. So how do they synchronize these processes? We will block the producer when the buffer is full, and we will block the consumer when the buffer is empty. In other words, the producer puts information into the buffer, the consumer takes information out. Well, the consumer can't take anything out if the buffer is empty, and the producer can't put anything into the buffer if it's full. So it's just monitoring. It's like monitoring what's going on to know if the producer can go or not. Again, you can liken it to your real life. You're not going to put more juice in your glass if it's already full, or you're not going to drink your glass of juice if it's empty. So a situation, now this is the race condition. What's the race condition? So these are just some key areas that are concentrated on and are given names. Again, if things are given a name and they're even given code and they're giving, examples, that means there's something important for you to understand. So race conditions. This is a situation where several processes access and manipulate the same data concurrently. And the outcome of the execution depends on the particular order in which the access takes place. Is called a race condition. Again, back to my example with the customer. I can't send out a bill to a customer if it has the old address. So it has to have the new address before I can send out the bill. So to guard against the race condition, we need to ensure that only one process at a time can be manipulating the variable counter. So we make sure, again, synchronization. It's always a matter of somebody waiting. Critical section, I mentioned this before. However, your program has to determine, or you as a program have to determine, if a process comes in and there's some of the code that has to complete from start to end, you have to let it. So you have to have some flag, okay, that says, this is a critical section. So you have to have some way in your program to designate or show that this is a critical section. Maybe the process will come in. You want to also make your program general purpose. So a process might come in and say, hey, when you reach my lines of code, 5, 6, and 7, don't stop me, I have to finish 5, 6, and 7. So it's like passing a message and telling, the processor or the processor manager. So here's the solution to the critical section. Mutual exclusion. In other words, the process that has a critical section has to go through and can't be stopped. Progress, they have to go from the beginning to the end, and then there is an end. Somehow it has to be signified that there is an end. Otherwise, that process will just continue and continue, and that might cause a problem. So when there is a critical section, in other words, the process cannot be stopped when it's going through those lines of code. It has to make sure it goes through those lines of code. It can't be stopped in the middle of it. And also there's an end. Somehow there has to be a signal that there's an end. Two general approaches are used to handle critical sections in operating systems: preemptive kernels and non-preemptive kernels. You should be familiar with these terms. Now, what does this mean? A preemptive kernel allows a process to be preemptive while it is running in kernel mode. A non-preemptive kernel does not allow a process running in kernel mode to be preempted. In other words, this would determine if it's something that has to go from beginning to end, it's not going to be preempted. However, if there is a process that's some code that's not critical, and another process comes in that has a critical section, well, maybe that other first process can wait. So you have to allow for that option. Again, it all depends on the situation you have. Any questions so far? So we're looking at strategies of just managing these processes. We already found out that there has to be some way to show there's a critical section, determine if they can run at the same time or not, if they're sharing memory space. So all these conditions come into play. So when you are designing a program, you have to determine if any of these situations exist. If they do exist, then you have to pick the correct algorithm. Okay, so it's not clear. What can I help you with? What question do you have? Again, we have to think in a general term. This is the real world, and we have a lot of processes that are going on, and we have to figure out how we can manage all these processes without making any confusion. So then we're going to take a look at our processes and determine, okay, can these processes just run the same time and it doesn't matter in what order? Then nothing much has to be done, just let them run. But if there are some sections of this code that has to begin and start and cannot be interrupted. For example, if you're updating a record, okay, I got a new customer, and I'm going to put in the name, I'm going to put in the first name, I'm going to put in the last name, and I also have address and telephone number. Well, I can't be stopped in the middle of updating this record because I can't have a new customer with a new name, new first name, last name, but no address or new phone number. So that means I have to somehow tell the program or the processor that I have to finish completing this entire record before you can do something else. So it's a matter of your situation. It's just trying to emulate and make sense out of the real world. Okay, we have a lot of processes and a lot of resources, and we have to manage them. Especially, we only have a limited amount of resources. Example, if we have a requirement for memory, well, maybe the processes can share the memory, or we have a strategy where they share the memory. Well, if they share the memory, again, we got to make sure they don't get confused and mix up the memory. So all these strategies are just a way to look at our scenario and determine if there is some order we have to put to the way our process executes. Depending on our scenario, will determine what we have to make sure has to be done. Does that make better sense to you? Is that clearer? Okay. So again, they sound complicated. They sound, especially when they start putting in, you know, P, and they use mathematical symbols. They start getting complicated. But again, mathematical symbols are just a way to make an objective solution or a model. However, when you start applying it to programs and processes and scenarios, then you don't have to be so detailed. You can give names to things. It's not going to be PI. PI doesn't sometimes make any sense. But it could be updating a record, or as our dining philosophers examples. So that's why they bring these examples into real world type of scenarios to help it make more sense. So looking, if anything, if you look at how these problems, like the dining philosopher, Baker's algorithm, or reader-writer, producer-consumer, if that makes sense to you, then you understand the solution. So if you don't understand when it uses P's and I's and numbers here, numbers there, then start putting words to it. If you put words to it that make sense to you, then it's going to make sense to you. So hopefully that'll help. Peterson's solution is another way. Again, these are just particular solutions based on a specific scenario. We looked at what happens if they have to share data space. We looked what happened if they have a fixed buffer. We looked at how to deal with it if there's a critical section. We looked at how to deal with it if there's a race condition. So it's just looking at example scenarios that illustrate or have those characteristics. Then if they do, then use that logic. As simple as that. Okay, so Peterson's solution is restricted to two processes that alternate execution between their critical sections and remainder sections. Again, this is just a way to deal if a process has a critical section. Now, if it has a critical section, that means there's some code of it that has to continue before it can stop. It has to go from beginning to end. Updating a record is an example. And if you have two processes, well, I have to update the record before I send the customer the bill. Now, mutual exclusion locks. This means, okay, this is when I actually make sure one process can only be processing at a time. Now you can use hardware. There are actual hardware and locks and signals. If you ever take a hardware-oriented course where you look at the circuitry of how a computer works, there are actually gates. Gates are open, meaning a signal goes through. Gates are closed, meaning signal cannot go through. So when you use hardware locks, that means exactly what it suggests. The gates are locked. So if I have a process that's processing and it cannot be interrupted, that means all the other processors have locked gates. They can't get through. But we're not going to make a new hardware set of locks and gates every time we have a new scenario. So that's why we're using software to do this. So the software will help solve the critical section problems. And the simplest of this is the mutual exclusion. Again, it's just a logic. It's just when you're allowing a process to process or not process, and we use it to protect critical regions. Again, it's similar to if you ever used an application or looked at a document and it said read only, or you did a spreadsheet, it says locked for editing, meaning someone else was using it, they are changing it, you can't. They have to finish changing it. Same thing with databases. You have to update a record before someone else can view that record. It has to be completely updated, not just part of it updated, all of it has to be updated. So these are just simple examples of these kind of locks. Locked databases, locked spreadsheets for editing. Very similar for operating system. Well, the memory is locked for this process. They can't use the memory. We're talking about spreadsheets and databases. When you're talking about operating systems, you're going to talk about the processor. Well, the processor, you can't use the processor because someone else is using the processor. Or you can't use that memory space because someone else is using that right now. So again, it's just a matter of designated who can use what and when. And then you have to determine, again, by what's important or what's not important. So that's where you're going to get your critical sections, your race conditions. Mutual locks is how you put it into software. How do I do this? Well, I'm going to stop somebody from doing something until the other one is done. So they can either wait, they can go to sleep. Several kinds of situations here. We have release and acquire. So release means I'm done. Acquire means I need it. What is it you need? Well, whatever you need. Do you need the processor? Do you need memory? Do you need, what is it that you need? So if we're looking at processors, well, I need the processor right now, and I need it until I'm done with this bunch of code, the critical section. Remember, the critical section is just some area that has to begin from the beginning and cannot be interrupted until it's done. So what I'm going to do is lock out any other processes. So when I have it, you can't use it. However, I got to make sure when I have it and I'm done, I release it and I give it back. Now releasing, you can kind of simulate this to when you have a lot of windows open. When you are using your computer, you have a lot of windows open. Well, all those windows are using memory. But when you close a window, then you're releasing that memory for somebody else to use it or for another window. So that's why it's important when you are using your computer, don't have so many windows open or don't have so many processes running, because it will slow down your computer. And it may come to a point where you can't run something because there's no more memory left. So that's an example. So that's the release and acquire. Now these are just some syntax code that is used for programming languages. They have to have some way to offer you a way to make a process stop and start and wait. Semaphore, very similar. You have wait and signal. So these are just coding logics to make something wait, or if there's some code that has to finish, then it has to be finished before it's interrupted. P-threads, something we'll be looking at in programming. Threads, usually these classes. These are objects that are in object-oriented programming languages, and they have a way, then they have a method that means to lock or not lock. They have variables to lock until this happens, unlock when this happens. Read-write locks. You can't read something until it's completely written. Okay, so any questions on chapter 6? Again, it's a lot of different logics, but if you look at, again, we're going to look at some real-world examples like the dining philosophers, Baker's algorithm, reader-writers, the sleeping barber, and our sleeping teacher assistant. It's just 4 specific types of scenarios where you need to have some locks, you need to have some mutual exclusion, you need to have some semaphores. In other words, for our teacher assistant program, you can't have a student sit down if all the chairs are full. And the teacher assistant goes to sleep if there's no student to help. So the scenario kind of gives you a clue as to what you need to lock and what you don't need to lock, or when you need to lock something or don't. So we know that these locks happen, but it doesn't really make too much sense until we actually start using it. When you start using it, then it will make a lot more sense. So if you're having a hard time grasping this now, again, that's why they make these real-world scenarios for you so that you have a better understanding when to use a lock or not. You will know automatically when you read the scenario. It's going to be very clear to you. Obviously, you got to think about it. But again, a teacher assistant can't help if there's no students, so a teacher assistant sleeps. A teacher assistant, if they're helping a student, cannot help another student. So you lock out that second student. Does that help makes more sense out of some of these algorithms? Yes? No? Are we okay? Any questions so far? I know you're all anxiously waiting to get to the program. Okay. Again, you are required to be here in this virtual session. So I will be taking a list of the participants. So hopefully you're all here now. I will be doing that list now and saving it. So if somebody left, they came back, make sure to have them let me know they came back and they're not on this list. Okay, if you can give me just one moment, let me just take oops. I don't know how much of my screen you're seeing on your screen, but this is what I'm doing right now, just to be quick. So, hopefully you're all here. Okay, now, Chapter 7, a deadlock. Okay, this is when we have a problem. Okay, a deadlock can occur only if 4 necessary conditions hold simultaneously. Mutual exclusion, hold and wait, no preemption, and circular wait. So, to prevent deadlocks, we can ensure that at least one of the necessary conditions never holds. Again, this is writing a general purpose type of a program, and you have to have some signs or flags to let you know if there's a problem that may show up. Now, if there's a problem that shows up, you've been there, though. Not all programs are perfect. Not all operating systems are perfect. Unfortunately, they try to catch most of the issues and problems that may occur. But if you ever had your program crash, well, you experienced the problem. But we try to do our best. Again, deadlocks are also, this will apply to networks as well. So again, a lot of these algorithms are not just for operating system, it's just a demand for a resource, no matter what that resource may be. It may be multiple users, it may be the CPU when you're talking about an operating system, it may be a network server when you're talking about networks. So it does apply, but there has to be some strategies when we write our programs so we minimize how many times it deadlocks, or to try to recover if it does deadlock. What do we do? I mean, we can just have it go into an infinite loop, but that wouldn't be a good thing. So deadlocks occur if we have mutual exclusion, hold and wait, no preemption, and circular wait. So just know that. Methods for handling deadlocks. Ensure that the system will never enter a deadlock state. Allow the system to enter a deadlock state and then recover. Or ignore the problem and pretend that deadlocks never occur in the system used by most operating systems, including Unix. And that's why operating systems crash. But sometimes they just continue going on, even though a process may miss a couple of lines or steps. Maybe it'll be okay even if it missed those steps, or maybe it won't be okay if it missed those steps. But if we let it just continue, then at least we know the computer doesn't crash, but there might be some wrong operations that happened. But again, that's why sometimes when you get a report, it has to be checked. Or if you write a program, just because you got results doesn't mean that it ran correctly. You got to make sure the results are the ones that you want. So deadlock prevention, do know how to do this. Do understand these. I'm going to kind of flip forward a little bit only because I want to start talking about our program. So learn about deadlocks. You have when to recognize it, how to prevent it, how to avoid it, how to get a safe state. Again, just look at the terms. If you think about the terms, then they'll kind of be ways to analyze a situation. So deadlock, unsafe, and safe. Obviously, if it's an unsafe state, that means a deadlock will occur. Obviously, you always want to keep it in a safe state, and that's you as a programmer, or anybody as a programmer. You have to anticipate what's going to go on with your program. You have to anticipate what a user will do with your program. And you always try to keep it in a safe state. For example, if you have a user supposed to enter in 1, 2, 3, you got to make sure and check that they enter 1, 2, 3. They don't enter ABC, and then you let your program go. So it's a lot of strategies to anticipate what might happen and to catch it before it happens and recover from it. Or sometimes it's such a rare situation that it maybe happens 1 in a million, so you're not going to worry about it. Typically when you do software development, you do as a risk management plan. And that's exactly what a risk management plan does. It identifies, okay, what risks do we have? Are we going to run out of memory? Or are we going to run into a lot of deadlocks? So you're going to determine, well, there's some risks that might happen, but they're going to happen so infrequently that you don't worry about it. Or there's some that may happen, and there's a high probability it will happen. So you're going to have to write some code to make sure that you address it. So these are the detection algorithms for deadlocks. That's just to see. Again, you're going to try and catch. If you did any error handling in your Java programming or in any programming, error handling is similar. You want to see. If it might happen, then we got to prevent it before in case it happens. Okay. So, understand the deadlocks. We can talk about it again, but I think it's pretty straightforward. Now, I want to now go to these problems that were discussed in your textbooks. Again, I have videos on the announcements page for you. I also have links that go over the logic. Again, it's a matter of understanding the logic. And then, when you have to write a program, you have to determine which scenario is this similar to. Whichever one it is similar to, then that's the logic you will use. For example, for our sleeping teaching assistant, that's similar to the sleeping barber. So look at the sleeping barber. I did give you the Java code. You do have Java code for some of these problems with the videos, and there's also Java code in the discussion forum. So the discussion forum, just as a quick recap, you do have to respond to the article. You do have videos and also read the chapters. So the discussion question is to respond to this. What do you think about it? So offer a 200 to 500 word response. Bring in some references and resources. That would be a good way to research it. But this, again, a lot of the stuff we're discussing, some of it is actually used and applied, but some of it is just in theory. There are models, but not all models are used. So this is a way to learn about what the models are out there, because maybe one day these models will be used. So it's always a good idea to have access to and keep up with the latest research that's done in an area. It's good for you, it's good for your employer, that you know what you're doing and you know what's going to happen in the future. These are the exercises from your textbook. So one's on race conditions. We did discuss race conditions. That means something has to be done first before something else can continue. And this one is using request to release. And this discusses deadlock. So as you complete these exercises, you'll get a better understanding of those topics. And then the programming assignment. The sleeping teaching assistant. Again, just so you know, let me get to that part. This is the description. Here we are. But here we go. If you get the remember, it's only 20 points. 20 points out of the entire course is a small portion. So don't get so pressured and stressed about it, but you will have all session to work on it. However, you have to give me something on Saturday so I can give you some points. These are your options. If you do complete it and it runs successfully, you get the full points. Now, if you started and you have some code, the logic is correct, but it doesn't run, you still get credit. But if you want more credit, again, you can keep working up on it until the last day of class. And then 10 points if you do the class diagrams and flow chart. I did mention that in the office hours. I did give you the problem solution in C code. So if you want to start with that, you can get partial credit, and then you can continue working on it to get the rest of the credit. So that is up to you. Or another option is, I did give you, there is some Java code posted for the sleeping barber. If you can get that one running, you have all the code. No, the article is not graded. So the article, great question. Yes, it's 0 points. So it's just a matter of something to discuss, but it's something good for you to read and know about. So that's why I have you just posting your answer in the discussion forum. So hopefully you will get to it. But again, you can post if you have problems with any of your exercises, any of the homework problems. Do post your questions. Maybe you can collaborate on this assignment, the programming assignment. Again, it all depends on how much you want to be a programmer. Yeah, it's good to be a programmer. But programming takes time, especially to do it right. So that's why I'm going to give you all sessions. This does apply to all programming assignments. Give me something on the Saturday it's due, just so I know you are thinking about it, you are working on it. I'll give you some points, and then you have all the way until the last day of class to finish it. If you want, that's up to you. You know, you may still get an A, even if you don't finish these programming assignments, because there's a lot of other points to get. So that's up to you. But of course, the more the better. The more you know, the better off you are. Knowledge is power. So those are your options. Finish it. If you have it, 20 points. If you almost have it, 15 points. If you started it, 10 points. Or the sleeping barber. Any question on this so far, at least how to handle this programming assignment? And again, this will apply to all programming assignments for the class, so you don't have to get so worried and stressed about it. You will have time to revisit it and finish it up until, I don't know, we have 10 weeks left to the last day of class, whatever the last day of class is. But give me something to know that I know, and you have something in the grade book that at least you were thinking about it. So, you know, you could start, again, you have the logic already in the C programming code, so you can just do a flow chart on that. Class diagrams, you have an example of the structures in the C programming language, so just determine how you may want to put it in Java. This is the sleeping barber. So sleeping barber is very similar to your sleeping teacher assistant. So you do have the Java code from this. So here is just some logic or a run through. This is like the pseudo code. You're quite welcome. I'm glad I know I've been there. I want you to understand and not to, you know, work to do anything. So hopefully you will have the time to do that. And if you don't do it, that's okay too. Just turn in something. But again, these programming assignments are a small part of your entire grade and final grade. But again, if you have the time and you want to do it and you like to do it, then by all means do it. But not if it's going to make you take a hammer to your computer because you're so angry and frustrated, then no. Maybe, I mean, there's a lot of areas in information technology and computers that you should find something that you like and have a passion for, because then you don't mind sitting hours learning about it. Okay, so this is pseudocode. Hopefully, does anybody have any questions on this? We did talk about weight and signals. Okay, so these weights and signals are here. So again, you have mutual exclusion locks here and semaphores. We did discuss, we did just look at it, it is mentioned. So again, a lot of the stuff you're reading in the textbook makes more sense when you apply it to an example. Instead of, again, using some of those logical mathematical symbols that are used for a theoretical model. But when you start applying it to real world, it makes sense, like waiting for chairs. This one is the sleeping barber. In other words, they're going to have customers waiting in chairs, similar to students waiting in a chair. The teacher assistant will help a student, whereas the barber will cut the customer's hair. So hopefully you can get some sense out of this. Again, you can get 10 points if you at least start looking at the logic, create a flow chart, and then create your class diagrams for at least a teacher and a student. You do have the C code for that. Here are some links of how to write threads. You're going to be using the threads in Java. Again, I have example code. If you look in the office hours slides, you have Java code for the dining philosophers, banker's algorithm, and now the sleeping barber. So hopefully that'll help you then to learn how to write it in Java as well. The logic you have in the C code. So here's some more resources. Again, I will put these slides in the discussion forum for you to look at. There's explanation on how to write Java processes and threads. The runnable. Runnable is the interface you use. I did mention before a while back, when you're using an object-oriented programming language, you will have a class hierarchy. There are things from the library you will use, and there's some things you will customize or create for your specific program. For example, you're going to be creating a teacher class, teaching assistant class. You're going to be creating a student class. And then you're going to have them run in the form of processes and threads. And you're going to have them run. That's why it's called a runnable interface. So if you go back to this example, when you have runnable, that means, if you remember, your Java implements runnable that deals with, it could use it and then make specifications about it. So run is when you get a thread to start. Excuse me. Run is a method that you need to have so that a thread will run, and start is the method to start a thread. So really it should be run. Instead of run here, it would be better, it would make more sense if it was start. But think of it as the same. You need to create this public void run in order for your .start to work. .start will then look for the run and then actually process it. So again, hopefully you want to know your Java and write the program. If not, we could do the logic. And again, there's additional information in the week 4 forum and the announcements page. And then here's week 5. No program. You can do it depends on how much you do. You can do the Java file, especially if you're going to have the Java file if you started to run it. If you're just doing a flow chart and class diagrams, then it would be a Word document. If you have the Sleeping Barber program that you're running, you can give me screenshots. If you have a successfully running program, then offer me screenshots of the output screen so that that'll show that you ran it and it did display some output. So for all executed programs that actually are running, give me a screenshot of the output screen. And if you have Windows, you could use the snipping tool. The snipping tool is the tool that is used to capture a screenshot. Okay, so any questions so far? Again, work together on this. You all can work together on it. Bring your questions into the discussion forum. I will see if, it's better to put it in a discussion forum so everybody can see your question and everybody can see the answer, because they might have the answer or they might have the same question. So emailing it to me is just for me and you. But this way, if you put in discussion forum, the entire class can work on it. If you have some progress on stuff, bring it into the discussion forum. So this is where you can share everything you do for this programming assignment together. And hopefully you'll understand it. Again, don't just copy and paste something. Say one of your classmates actually run it and have it running successful. You could submit it, but make sure you understand it and why it works. And also, make sure you could run it. And then even see if you could do something similar and make it running yourself, because you won't have that person around when you're going to be having to do a program by yourself. In the classroom, you may be able to copy classmates' assignments. However, when you're working and you're in the workplace, you can't do that. And you're not allowed to copy stuff. That's when they really will know if you understand something or not. So you can't fool your boss in the workplace. Here you can work together because it's like a practice environment, but you still have to know it. Copying and pasting doesn't help you learn it. Even if you copy and paste it and put it under your pillow, you still won't learn it. You have to really understand it. Okay, so any questions? Again, let me just go back to maybe that slide about, here we go, grading criteria. Again, you have options here, and then you can keep working on it. So this way you're not too stressed about it. Do read the article, start a discussion on that. Bring your questions into the discussion forum on this. Hopefully this is helping you more in understanding the logic. This right here is very similar to what you need to do. And again, go through your C code solution. And go through the Java code for the Sleeping Barber. Right here. Here's the code. I have the link for it. It's right here. So this is the Sleeping Barber code. Again, it's very similar to the Teaching Assistant program assignment. So hopefully with all these, I know you're all smart. You'll be able to figure it out. You'll be able to get the logic understood, and that's the most important, is the logic. Okay, with that, good, I'm glad. And I'm also here to work with you. I'm flexible. So I just want to know that you're trying. And again, you have the whole class to do all your programs if you want. If not, you will get credit for whatever you do. So yes, you will be rewarded, just so I know that you're thinking about it. Yes, I will put this PowerPoint in the discussion forum, so you'll have this information. So I do have the office hours, the other one, and then I will put that. Okay, thank you so much, and have a great evening. And don't hesitate to contact me, contact your classmates. Again, we're all in this together. So let's help each other out in understanding it. And I think you'll do just fine. Okay. And don't forget, I did take a participation. I did say